This is sample problem 5.9. The common configuration of a reciprocating engine is that of the slider crank mechanism shown, which is this figure that is shown here. If the crank OB, so this is OB, has a clockwise rotational speed of 1,500 revolutions per minute, determine the position where theta is 60, so we know theta. The velocity of the piston A, so this is piston A, so we have to find the velocity of piston A, which is VA, and then velocity of the point G on the connecting rod. So something like V of G, and the G is right here on the connecting rod, and the angular velocity of the connecting rod. So also we need to find omega of the connecting rod, which is the angular velocity for AB. This is the connecting rod. So we have to apply our relative velocity, and remember that the relative velocity equation is, if you have V of A is equals to VB vector plus VA with respect to B vector, and the crank pin velocity, which is B, the crank pin velocity, which is VB. We can find this because we are given that it has 150 revolutions per minute. And I've converted these distances into meters because in your textbook it's in feet and in inches. So if you look at this, if you convert this into velocity, it will be what first we have the rate I is 0.1, 0.13 times, then we have 1,500, multiply this by 2 pi, and you divide this by 60 because it's in minutes, you convert it to seconds, and if you compute this, it will give you 20.42 meters per second. So we have our VB. Note that this is coming from the equation, knowing that V is equals to R omega. So this is our R, and this is our omega. And so now we have it in meters per second. All right, now we know that our VB will be normal to our rod OB. So if you look at it, this is the rod OB, and this rod is going this direction. So it means that at this point our velocity will be tangent to that. So this is VB, and so this will be right angle triangle. So if you go on with that, we know theta to be 60, so this will be 30. But this is not beta. This beta is between this and the horizontal. This is beta, but this is 30 because this is 90, this is 90, this is 60, so this will be 30. Now we know that our VA will be horizontal because if this goes this way, it moves in that direction. Our VA will be going in that direction. So what we have is our VA would be from this fixed point, this would be VA, and then our VB is now this direction. So that's our VB. We know that this is 30 degrees, and we know what our VB is. We don't know our VA. Note that our VA with respect to B will have to be perpendicular to the line AB, that is to this line. Let's get rid of this. So it has to be perpendicular to this line, that is VAB. And so we can find our beta here by using the sine rule. We know that from here point A to B will be 0.25 plus 0.1, that is 0.2, 0.5. So using the sine rule, we can then have 0.13 over sine beta is equals to 0.35 over sine 60. And then from here we can find our sine beta will then be equals to 0.13 over 0.35 sine 60. And if you calculate this, you find out that your sine beta is equals to 0.321. And beta is sine inverse 0.321, and if you compute this, you get 18.72 degrees. All right. Since we said that VAB is perpendicular to AB, which means it's perpendicular to this, this will be 90, and we've computed theta to be 60, and our beta to be 18.72. It then means that our angle between VA and VAB will be then 90 minus 18.72, which is equals to 71.28. So therefore we now have, if we draw the triangles again, we said that our VA is going that direction, and then we set our VB, and this is 30, which means that this is our VA of B, and we are now saying that this angle here between VAB and VA, that is this one, actually we've just computed to be 71.28. Therefore the third angle, this angle, will be 180 minus 30 minus 71.28, and this will give us 78.72. So this is 78.72 degrees. So now we have all the angles, and we have the vector triangle. This is a vector triangle, and we can now use this to compute the different velocities. So we can find, for example, VA. So VA, and to find VA, we have to say VA over sine, using the sine rule, 78.72 is equals to VB. Because we already know VB, we calculated VB to be 20.42 over sine 71.28, and so from here we get VA to be equals to sine 78.72 over sine 71.28, multiply this by 20.42, and if you calculate this, you will get 21.14 meters per second. Next, we can also find our VAB, which is also unknown, using the same sine rule. We say VA of B over, so it's VA of V over sine 30 is equals to, we still return VB that we already know, so 20.42 over sine 71.28. So VA of B will be equals to sine 30 degrees, these are all degrees, over sine 71.28 degrees multiplied by 20.42, and our VA, if you find the sines and you calculate that, you should get 10.78 meters per second. So we have the velocities computed. We have velocity V of A and we have VAB. We can then find our angular velocity omega AB, which is equals to VAB that we have computed over the line AB, which is this distance AB. So this will give us 10.78 over the line AB will be 0.35 meters. And if you calculate this, you should get 30.8 meters per second. Next, we need to determine the velocity of G. And this is known, G is along the AB rod. So we have to determine find the velocity of G. So we can write our relative velocity equation as V of G is equals to V of B plus, instead of AB now we have V of GV, where our VGB will be equals to our line GB, which is our R, multiplied by omega AV. Note that since they are on the same road, that omega AB will be the same as omega GB. So in this case, this will give us VGB will give us GB. We know what GB is, which is G, but let's just write GB. And then omega AB will be velocity AV over the distance AB. So over AV. So our VGB is equals to GB. This is GB, which is 0.1 meters, over AB. AB is 0.35 meters, multiplied by VAB, which we calculated to be 10.78. So our VGB will be 3.08 meters per second. All right, at this point, the only thing that is left now is for you to find VG, and I would like you to go through your textbook and see how this is done and complete this part. It will require you drawing the vector triangles to scale and then measuring it and then obtaining the right answer. Should be approximately between 18 and 20 meters per second. But please try your hands with the vector triangles and see if you come up with the right answer that will fall in this range. Thank you very much, and yes, I'll see you again in the next time we meet.